Howdy, howdy. This is Mr. Potter. We're continuing our work with the 11s game, and so what we're going to do today is implement some of the logic behind the game. Remember, the whole idea behind playing the game is that we want to select cards that add up to 11, or we're looking to select a Jack, Queen, King combo. And so I really want to start first with these contains pair sum of 11, or this contains Jack, Queen, King. The thing to remember, though, is that we're getting a list of cards. For the contains pair sum 11, we don't necessarily know if we're getting just one card, or we don't know if we're just getting two cards or a whole collection of cards. And the reason I bring that up is because up here we have this method that says if another play is possible, and if it's possible to find a pair of numbers that add up to 11, maybe not the ones that we've selected as a player, but if we were to go through all the possible combinations, then we could verify if a given pair adds up to 11. So we're going to go with that in mind. The idea that the array list here for this contains pair sum 11 may not have just two cards in it. And so we really need to kind of do this as a for each loop. So what I'm going to do is I'm going to say I'm going to go ahead and start with saying card C1, C2. I'm not going to assign them anything yet. I'm going to say for int I gets 0, I is less than selected cards dot size I plus plus, and in here I'm going to say, if selected cards dot size is greater than I plus 1. And the reason I'm doing that is because as I iterates, it's going to be hard for me to check all the rest of the cards up to that point, because if I'm looking at card 2, because I happens to be 1, there may not be more cards in there. But if it does exist, then I can go ahead and check these. So I'm going to say for int j gets I plus 1. J is less than selected cards dot size J plus plus, and then we can actually implement the logic here. So we can say up here I can say C1 gets I can do selected cards dot get I, and then down here I can say C2 get selected cards dot get J, and now I can make the comparison. And of course, keep in mind, these aren't cards, these are just these are card positions. So this is actually going to get the index of this. So I actually want to go up to my cards array. Remember, we have an array up here called cards. So I actually want to get that card from that position. The elements of this array list are just integers, so I want to get cards sub selected cards sub get I, and I want to do the same thing down here. Cards sub selected cards dot get J. And then what I want to do is I want to say if C1 dot card value plus C2 dot card value is equal to 11, then that means that this works, and we're going to go ahead and return true. So in other words, if we have card 1 and card 2, I in this case would be 0, J would be equal to 1, and when I retrieve these cards, if their values add up to 11, then we're going to return true. But also, if I'm going through a list of all the cards, and I want to know if such a play is possible, if an 11's play is possible, I can put all the cards in here. In this case, I may be position 4 and J be position 7. That gets me a true. But if I get through all of these nested loops, and I haven't hit the return true possibility, then I really should return false. So let's go ahead and explain what we got here. I have two variables for cards, C1 and C2. And I'm going to go through and I'm going to find a first card. And of course, I'm talking about a first card. This may not be the first card in the list if I'm looking at the is the play possible. But if this is what the player selected, this will be the first card. And then I go through this loop here. Actually, I go through this if statement here, and I say is a second card possible? In other words, if I'm at card 9 for the first card, if I ends up being the last card in the list, I want to make sure that there is another card that's possible to get. So if another card is possible, what we need to do is find a second card. And then what I want to do is I want to compare the cards. And I want to return true if it does contain a pair that adds up to 11. And if I go through all the possible cards in my list, and I ever get a situation where they don't add up to 11, and then I'm going to go ahead and return false. And of course, there are two conditions. I'm looking at it for pairs. Like if a pair of cards is selected by the user, by the player. But I'm also looking at it from the standpoint of this another play is possible. Because if another play is possible, that means can I find a pair that add up to 11? I'll probably need to go through all the possible positions. So here we've got this contain pair sum 11. We're going to do something similar for the contains Jack, Queen, King, but in order to do this, we need to know, do we have a Jack, do we have a Queen, do we have a King? So first thing I'm going to do is I'm going to say if selected cards dot size is less than 3, we're just going to return false right off the bat. There's no possible way that we're going to have a chance that they add up to a J, Queen, King. We could put something similar up here for the contain a pair. Basically, if selected cards dot size is less than 2, there's no possible way to contain a pair if there's not a pair of cards, and so we just return false here. It's probably a good idea to check it just for simplicity's sake. But if we get past this step and we get past this saying, yeah, okay, there's at least 3 cards, I wanted to declare some booleans. So I'm going to have a boolean called Jack, Queen, and King. And what I want to do is I actually want to say, I want to start off, Jack gets false, Queen gets false, and King gets false. Basically, I'm saying that I've started this and I have not found a Jack, Queen, or King yet. And then I want to go through the whole list. So for I'm going to say integer I in selected cards, and I'm going to do the following. I'm going to get the card out. So card C gets and I want to do cards sub I. So this is going to get the ith element of that array. And then if, and at this point I want to check the name. Now keep in mind that when we had our card names up here at the very beginning, where we set these up, we have Jack, Queen, and King for our ranks as uncapitalized. And so I need to check that here. So if C dot rank dot equals Jack, and if that's true, then Jack is going to get true. And I want to do the same thing for Queen and King. So as I go through the list, if any of my cards is a Jack, Jack is going to become true. If I've selected two Jacks, then it becomes true and becomes true again. That's not going to be a problem. The only issue is if I go through all of my cards and I never find a Jack. If I never find a Jack, then Jack is going to stay false from this declaration. And we can do a comparison at the end. So if I have a Jack, then return true, and I want to do the same thing. If C dot rank dot equals Queen, then Queen gets true, and if C dot rank dot equals King, then King gets true. And once I've made it through this loop, I've checked all the cards, which will tell me if I found a Jack, Queen, and King. And as we mentioned before, there are two possibilities. Either the player has selected three cards, and we're checking to see, of the three cards, do we have a Jack selected, a Queen selected, and a King selected? Or we are the game itself, and we're saying, is another play possible? So we're saying, is there any Jack, Queen, or King in the list of all of our valid cards? So this is what we're doing, and we want to return the result. So I want to know if Jack is true, and Queen is true, and King is true. And the thing is, if any of these are false, if any of these stayed false from my original declaration, it means that the card missing, and so I don't have one of those triples, Jack, Queen, King. But if all of them become true, then this AND statement will evaluate to true, and yes, I do contain a Jack, Queen, King. So this is one way of looking at how do I know if I'm going to have a Jack, Queen, or King here. So I've got a method that sees if a list contains a Jack, Queen, and King. I have a method that sees if we contain a pair of some 11s. There's two other methods that we have to look at here. One is the idea is if the play that the player has selected is legal. So if a play is legal, keep in mind that there are basically two legal plays. Okay, the first legal play is does a pair sum to 11? So there's really two questions I have to ask. Is it a pair, and does it sum to 11? So if selected cards dot size is equal to 2, and we need to know, do we contain a pair sum 11? So if this is true, then that is a legal play, and we're going to return true. So the other legal play is, do we have a Jack, Queen, King triple selected? So is it a triple, and does it contain all the cards? So if we're going to have to check the size again, so if selected cards dot size is equal to 3 and contains Jack, Queen, King, and remember, I need to pass selected cards as a parameter, which I forgot to do up here. I need to take care of that. So selected cards. So if this is true, then we're good. We're a valid play. But if I make it through here, there's no other valid plays, so we're just going to return false at this point. So when we're trying to determine if a play is legal, first thing we want to do is see, okay, do we have a pair that adds up to 11? And that's what we're checking with for these two lines here. So if the pair actually does add up to 11, do we have a pair? That's the first thing we check. And does it actually contain a pair that adds up to 11? If that works, we're a valid pair. play, we return true. Then we check to see, okay, are we a Jack, Queen, King? So if our size is the appropriate size, we only have 3 cards selected, and they include a Jack, Queen, and King, then we know that's a valid play. Nothing else is going to be a valid play for us. So this determines whether or not a given play is a legal play, which really only leaves one thing left for us to determine: is there some other play that's possible? So let's go ahead and take care of that. If I want to know if a play is possible, I actually want to go through and find all the cards that have valid positions in them, and I want to send that array to selected cards to check to see if there is a pair that adds up to 11, or if there is a Jack, Queen, King. So I need all the cards here. So I need to create a list, a list of type integer called selected cards. Gets new array list of type integer. And what I need to do is I need to go through cards. So for cards C in cards, and I want to know the following. Actually, just going through with the for each isn't going to help. I really need the index of the array. So I have to go through the array to do this. So int I gets 0, I is less than cards dot length I plus plus. So let's see, it was cards was an array up here. Is that what I have up here? Just checking again. Yeah. So what I need to do is I need to go through all of those spots, and I need to check. So the first thing I'm going to check is if cards sub I is not equal to null, because if it's equal to null, then that means there's no card in that position. This is going to happen in the late game. If I don't have a card in that position, then there's no purpose in adding it to the list. So if card sub I is not equal to null, then we're ready to add it to the list. So we're going to go ahead and selected cards dot add, and we're going to do a new integer I. I know I could just put an I there, but keep in mind this is a list. List can only contain objects, and I really need to make sure I actually have an integer object here. So this is going to put all of the valid cards, the cards that we have in play, in our selected cards list. And now what I want to know is do I have possible plays? So I want to return contains pair sum 11 for selected cards, or contains Jack, Queen, King for our selected cards. And of course, notice the way that we wrote these two methods earlier. If it doesn't depend on the size of the list originally, for the contains pair, I'm not only looking at a pair, I'm looking at every element in the list to see if there's some other card in the list that adds up to 11. And when I'm looking at the list, I'm just going through the entire list and saying, is there a Jack? Is there a Queen? Is there a King? So I've got these four methods. Let's go ahead and compile this and take care of any really horrible errors we've got. We've got a few. So let's take care of those. Selected cards dot size. Size is supposed to be a method. So let's go ahead and take care of that. That's on line 239. So on line, let's move this down a bit. So on line 239, this is supposed to be selected cards dot size. But then the other one I need to look at is on line 250. I've got C1 dot card value and C2 got card value, and it's saying it has a problem with that. So let me jump back over to card, and the method is point value. Okay, so just point value, not card value. Okay. The idea is the important thing here, and of course this is just making sure that it compiles correctly. So let's compile it one last time, and it appears to work. Excellent. So let's take a look at what's happening here. The first thing that's going to happen is we're going to go to our constructor. Our constructor says cards gets new card of board size. Board size is this instant value, which is 9. I could make the board bigger if I wanted to, but I'm not going to worry about that. We're going to create a deck of cards with the given rank, suits, and point values, which we've got here as static final values. We can print out the deck. We can print out a dash line. We can go to deal my cards. So we're going to go to deal my cards, which is down here. Did I lose deal my cards? Okay, I've got new game, I've got size, I've got is empty, I've got deal, I've got deck size, I've got card at, replace selected cards. I've got card indices. I've got 2 string. Game is 1. Is legal. Another play is possible. Deal my cards. And all this does is it basically goes through and gets a card from the deck using the deal method and adds it to our array. So that's our 11's board. Here is our new game, which is going to deck.shuffle and deal my cards. And we've got all these methods. So the question is, do we have any way to run this? That's really going to be helpful here. So in this folder, we don't have anything necessarily to run this. I'm going to jump over to the Activity 9 starter code because there is a GUI runner and a card game GUI. I'm not sure we're ready to run those yet, but our 11's board should run without a problem. Let's go ahead and will this run? I don't believe I have a main method yet. Yeah, there is no main method here, so we can't really play the game. The way we've got this set up is that this is only going to work for a GUI because we don't actually have a console interface that displays all of this stuff. So what we're going to do next time, now that we've got the mechanics of the game done, testing to see what valid plays we have, as well as whether or not valid plays exist, we're going to start talking a little bit more about the abstractness of this, because I've got this game, but 11's a completely arbitrary number. I could make this a game called 13s, and as long as I change the ranks appropriately, so Jack is 11, King is 13, Queen is 12, then I could have it where I'm just adding up all sorts of pairs, and 52 is nicely divisible by 26, so there's lots of pairs there. So we're going to talk next time about how to make this game board a more abstract concept. Remember, the idea of abstract classes means that we have some stuff that we're going to leave undefined, so we can't actually create an instance of a board, but our game board will actually end up extending it, because there's some stuff up here in here that really is going to be used no matter what. So once again, this is Mr. Potter. Thank you for watching. Have a great day.